Hi guys, I hope you are fine. Me too, I'm fine. So guys, today we are going to look at another topic. And guys, we've been looking at integration and even finding the area of the curve that is under the curve using integration method. So today guys, we are going to use what we call Simpson's rule. And for the Simpson's rule, it is required that we divide the curve. The area under the curve should be divided into even number of strips. And so guys, before we do that, we are going to look at, first of all, let's read the question. The question states, use Simpson's rule to find an approximation. I've written it I have tried to shorten. Of course, it's not written like that, but this is just a short form. For the area under the curve, y equals to 1 all over x, between x equals to 1 and x is equals to 2. And so guys, I am going to now look for values of x and values of y. And so guys, I can draw a line here like that and say that at my point number 1 is the lower limit and the upper limit is point number 2. So guys, I want to divide this one into even number of strips. For that, it means guys, I can choose several number of strips. For example, I can choose 2, I can choose 3, I can choose 4. But now guys, is because of the Simpson's rule, we cannot choose less than 4. And so I am going to choose 4, and I will show you why you cannot choose less than 4. So if we choose 4, we are going to have, like, for example, I can put a mark there, another mark there, and another mark there. So you find these are four strips like that. And we shall draw them later in our diagram, and you see them. So for us to find from 1 to 2, the values of x, we need to divide the distance from here to here. We divide by 4. 1, 2, 3, 4. So that will be 2 minus 1. 2 minus 1 is 1, then divide by 4. So that gives us now 0.2. Because of it, you remainder 2, then 5. So guys, we are going to have intervals of 0.25. And so those intervals will be, the first one is going to be 1 plus 0.25. That one gives us 1.25. And the second interval, 1.25 plus 0.25, that one gives us 1.5. So we have 1.5 there. And here we have 1.5 plus 0.25 to give us 1.75. So those are our requirements for x, so that we have the 4 strips. And remember, these are the strips we are talking about. These are the number of strips, 1, 2, 3, 4. But we shall draw them well later, because I have a diagram here where we are supposed to draw them. And so guys, my work is now to find the value of y. So the first case I have found, it's 1. The second case, I will come and write y is equals to 1 all over x is 1.25. And so y is equals to, I use a calculator, 1 divided by 1.25 equals to 0.8. So this one is 0.8, like that. I go to the next one. which is this is 0.8. The next one is y equals to 1 all over 1.5. This one gives me 1 divided by 1.5. This gives me 0.666. 0.666, which I can approximate to be 0.6. I can write 7 like that. Then I go to 1.75. This will be y equals to 1 all over 1.75. And this one I'll get 1 divided by 1.75. This gives me 0.5714. That is 0.5714. So I write that. That is 0.5714. It's almost reducing to 50, but we've been able to write it. So after that, guys, I can work with this, or I can, maybe because it's the first time, let me just try to draw the diagram representing that, or the curve. I mean the curve. So we have the first one we have is 1 and 1. So here we can say this, let's say this is 1. So it's going to meet somewhere at this point, guys. That is 1. And then we have the next one, 1.25. 1.25, then we have 0.8. 0.8 is around this position. I am just approximating, guys, that position. So it is not exact. It's an approximation, which you may not need to do this, but let's do it and see what we get. The next one is 1.5. We have 0.67. So 0.67 will still be somewhere like here, like that. We continue 1.75. This one is still down here. That is 0.5714, somewhere there. And finally we have 2, which gives us 0.5. And so, guys, we have something like this. So if we were to draw our curve, then our curve will run like this. It will be from here, and then remember that this is not a straight line. It's actually a curve. I can draw it like that. That is our curve. And we can also show the ordinates for that curve. The ordinates for that curve are as given below. This is the first ordinate. We have the second. We have the third, fourth, and fifth. And remember that these ordinates, guys, have values. They have values. The ordinates have values, and these values can be found on this axis. But these values are actually these ones. These are the values. So that here we have y, and here we have x. So the ordinates are found along this y-axis. And so, guys, now we come and calculate the area under the curve. This is now the area under the curve is what we are now supposed to look for. That area under the curve. So, guys, when we look for the area under that curve, we use the equation, and the equation that we use is given by area. That is the Simpson's rule. Area is equals to a third, that is a third, multiplied by the interval, into bracket, open the bracket there, then that is you multiply by what is inside the bracket. This is now going to be now the first ordinate, which let's say I can call this one x1. I call that one x1. I call this one x2, x3, x4, and this one x5. So the first ordinate and the last, that is x1 plus x5, like that. And then plus this one, now you multiply by 2. I come here 2, open the bracket, the odd ordinates, and the odd ordinates for us is x3 plus x5, that is now x3 only. So guys, for this one we have only that one ordinate, which is, because already we've taken this, guys, we've taken the last ordinate, which is x5 and x1, so we are remaining with 3. So we just take the x3 as the odd ordinate, and so this one we can cancel that and put a bracket there, plus 4 multiplied by the other ordinates, which are even, and the one we have here first is x squared, x subscript 2 plus x subscript 4, like that. So this is the equation we use, guys, to find our area. And so therefore we come here and now find our area. The area then is going to be equal to that multiplied by the interval. For our interval, we are already calculated to be 0.25. That is our interval. And this is how we found it from our calculation here. This was our interval in between the distance between the strips. And we see the strips are supposed to be 4. At least 4. Then this one you multiply by x1 and x5. x1 is supposed to be, now guys, we do not look at the x-axis, we look at the y-axis. For the y-axis, we have x1 being 1, this one, not this one, but this one, and the last ordinate is 0.5. So this one comes to plus 0.5 plus 2. Now we look for x3. For the x3 is coinciding with 1.5, so this is 0.67, 0.67. Then plus 4. Then we go for x2 and x4. x2 coincide with 1.25, that is 0.8, plus x4 coincides with 1.75, so it is 0.5714, 0.5714, like that. So this is now what we are going to look for. So guys, let's now find our area. So our area is then going to be, area is equals to, add here 0.25 divided by 3 equals to 0.083, 0.083 0.08, there is 0 there, 0.0083, then you put that. This one gives us 1.5, that is for 1 plus 0.5, plus 2 multiplied by 0.67, 2 multiplied by 0.67 gives us 1.34, 1.34 plus, now this one we are done with it, plus here we add these two and multiply by 4, that is 0.8 plus 0.5714 equals to times 4, so we get 5.4856, 5.4856, like that. So finally guys, our answer then should be equal to, we do that maths, this is going to be, we add that to 1.34 plus 1.5 equals to that, multiply by 0.083. So this one gives us 69.6910. 0.6910. So guys, here lies our solution. So this is our solution. Maybe we can write it units square because we are not given the units. Units square. So guys, we come to the end of our lesson, and that's how we find the area under the curve using the Simpson's rule. All we need to know is the equation, and then we are able to tabulate the table and get our values. So guys, thank you. God bless you.